Meet David. David is a rural farmer who has to travel for internet access. One day, David's friend Bill sends him an email about a 5G satellite launch. After reading the article about the satellite launch, he wonders if it'll bring better internet access to his home. While doing research on 5G technology, he encounters an image showing countless satellites orbiting the Earth. Curious as to why he gets poor service when satellites seem to be everywhere, he continues searching and finds an article looking at satellite launches over the past 50 years. The article draws him in, but he is unsure on how to interpret the visualization that's been presented to him. He is confused about the correlation between a data point's position and magnitude. Specifically, he wonders why many more tech and science satellites are being launched compared to communication satellites, as he has personally experienced poor internet connectivity. He thinks this is true because technology and science is placed a lot higher on the stack than communications. However, due to his limited knowledge about data visualizations, he looks online for lines with colored boxes of data, but nothing that looks like what he's looking at comes up.
On the other hand, consider the case where David has expert goggles. Expert goggles would automatically detect the visualization and classify it using a machine learning algorithm. By clicking the button and looking at the anatomy of a stacked bar chart presented by expert goggles, he can clearly see that the placement of the individual stacks within a stacked bar chart does not in any way correspond to their magnitude. Instead, it is the size of the individual section that corresponds to that section's magnitude. Excited by his newfound knowledge, David emails this article to his friend and confidently shares the insight he gained by looking at the charts. Supplying David with just-in-time annotations allowed him to learn while on task and be more confident when he sees other data visualizations on the web.
So let's take a closer look at how Expert Goggles is able to detect the visualization context. The first step is to listen for the functions that are being used to generate the data visualization that we're looking at. Then the function calls are compiled into a vector and classified by KNN. The result is then used to provide the contextually relevant guidance in the sidebar. Comparable to other state-of-the-art approaches, Expert Goggles has 80.4% accuracy and supports 12 different types of data visualizations. Machine learning models are rarely 100% accurate. This is especially true in real-world settings. This is why it is very important to think about what happens when a learning tool like Expert Goggles incorrectly classifies the context. Future research could also investigate mitigation strategies like this one when a context is hard to detect. In this example, users are given a choice to pick out what they're seeing. Future work could also examine the effects of a misclassification on a user's engagement, learning, and trust in the tool.